Okay, so today we're going to start looking at the topic of inheritance and polymorphism, which is essentially chapter 13 and 14. So what we have done so far is defining a set of classes and how do I design a class and decide what should be the attribute, what should be the interface. At this moment, hopefully, you know how to write such class, write a constructor, compile, link to the executable. And that's what we have done so far. So now we're going to introduce a concept called inheritance. So one of the things about designing a class is that the class is representing a concept. And we realize it's so powerful to be able to using an existing concept and extend it to another concept. And the thing is that will be very convenient for us to quickly develop more advanced concept based on some simpler concept. And therefore, this part, we want to convey what that extension really is in terms of in the language such as C++, and how do we actually write in code to be able to do that kind of extensibility. So I'm actually going to start with something fairly simple. I'm going to talk first about single inheritance. So in the history of object-oriented programming, there are two kinds of inheritance. In fact, there are more than two. One is called single inheritance. One is called multiple inheritance. There is another concept, which is in a different programming language. It's called prototype. Prototype is essentially saying that, well, I build a prototype based on the other prototype. So you can see that's another way of doing extensibility. And in C++, they further split multiple inheritance into multiple inheritance and virtual inheritance, which we will see the detail a bit later. But right now, I want to tell you two things. I'm only going to focus on single inheritance. And in fact, in my experience, single inheritance, in fact, is really the only thing you will need to do basically all kind of modeling. Anything that require multiple inheritance, you might be able to avoid it because multiple inheritance sometimes introduce complexity and sometimes really hard to maintain. So that's why I just want to let you know, sometimes more complicated language construct sometimes might not be the ideal choice if you can actually solve the problem with a simpler construct. So in this case, we actually have two classes. One is called box, one is called carton. So this is an example from your textbook in chapter 13. So essentially, I designed a class called box. And I want to actually introduce a newer concept, a special kind of box called carton. So that's why I'm actually using an inheritance relationship. So let me show you the syntax. The syntax is actually fairly straightforward. So when you define class carton, instead of putting nothing after the word carton, you put one single column, and then you have a mode of the inheritance. In this case, we say public. In fact, that's the most popular way of using single inheritance. We will see there's other option you can put here. So you said public and then box. This is basically the parent class, the name. So when you specify class carton, column public base, that means you make class box as the parent class, which the child class is class carton. So in English, once you actually define that, you essentially implement this sentence. You say carton is a box because it's parent. Okay, so whenever, for example, you say there is a class called student inherit from a person, so you can say a student is a person. So that's kind of extensibility. We'll see that. So that's why sometimes we call inheritance is a relationship. So in some sense, the concept of inheritance was actually developed by artificial intelligence when we want to represent natural language. In natural language, we would like to find out the relationship between two different roles in a system. That's why one of there are two kinds of relationships usually. One is called is a relationship. The other one is called has a relationship. In fact, you already see both of them. If you think about that, if you can represent is a and has a, essentially a lot of things you can do in the modern world. That's why, for example, the class Mark Carton has an attribute called material. So that is has a relationship. So basically what we learn from chapter 11, chapter 12, a lot of this is really implementing the relationship called has a. So it has a material. So now inheritance is a relationship. I want to represent this relationship. So let's actually take a look. So inheritance has a few important things, at least the property. Is an abstract concept. It's saying that, okay, if you represent a concept called carton, you base on the parent class box. So conceptually, I'm not talking about programming. Conceptually, you expect all kind of things you can do, all kinds of things you can have as a box that you should be able to expect. You will see the same thing from the new class you define called carton. So it actually provides abstraction to allow people, when they actually design a object-oriented system, they usually have this table. Okay, this is actually what we call, sometimes we call class hierarchy. Class hierarchy, this is an example. So you can think about it's a tree, kind of. And then at the end, there is something. This is, by the way, this is a multiple inheritance. Let me actually go through this picture very quickly. So this basically say, in the root of the class hierarchy is a community member. And then you have a 3 subclass is employee is a community member. A student is a community member. Alumnus is a community member. So that is a relationship as a single inheritance. You only have one single parent. And then the employee, you could have a faculty. Faculty is an employee, staff is an employee. That's another one. So that's also single inheritance. And then the faculty has 2 kinds of faculty. One is administration faculty and teaching faculty. So the administrator is a faculty, teacher is a faculty. So this, by the way, the inheritance relationship has a transitive. So which means that if a teacher is a faculty, is an employee, is a community member. So basically, when I declare a teacher, I'm expecting everything that's actually on the chain all the way to community member, that their property or their abstraction, I actually should have that. So you will expect a teacher behave or interact or react to anything that a community member should respond, should react. So that's a concept. You can think about it. It's a very nice way of abstract a relationship among a community like UC Davis that we can actually define things like that. So I mentioned there is something called multiple inheritance, which this is in your homework assignment. You will actually see that. So assuming there is a somebody who still is a faculty member, and he became an administrator. So he actually go over there. I mean, by the way, from 2014 to 2000, at the end of 2018, I was actually 50% hired as a computer science faculty, and 50% I was actually in the dean's office, is supporting the dean to do some administration. So at that time, I'm actually doing multiple inheritance. I'm actually here, but I do administration and the teacher. All right, so you can see that later we'll talk about administration. I will tell you multiple inheritance, when you first look at, it looks great. It looks great because it actually be able to represent a much more complicated concept than a tree. Because if I don't have multiple inheritance, all I'm going to have is very hierarchical. It's a tree. I cannot share. But multiple inheritance allow me to have this. I can actually represent a dual role. for a single entity. It actually looks great conceptually. But in the programming, this is actually something interesting. It takes time for you to understand this, for me to understand, sorry about that. Realize that multiple inheritance sometimes really introduce a lot of technical difficulty in terms of programming language, such that make the program much harder to understand. I will show you example later. But anyway, let's actually go focus on single inheritance. So single inheritance, you can see that we have, how do you declare that? You just say carton public box, something like that, and then you have that, okay? The second, there is a few things I need to talk about single inheritance. The first thing is this mode. I said it's a public, but this one could be protected, or it could be virtual. And there is a different way of specifying this. So I need to talk about that later. But also, you actually have seen my code. I actually usually put 2 or 3 keywords, public, protected, and private. And now with inheritance, with the mode we're talking about, those 3 keywords are going to make some difference, which is the important things we need to learn for today. Okay. Any question at this moment about why we want to do inheritance and the most simple way of specifying inheritance relationship? Any hands? It's kind of dark. I cannot see all of them. Okay. All right. Let's actually, yeah.
As that is just like putting an object of a class inside a new class.
Right.
Is that correct?
Right. And either basic title object has them. Yeah. Right. So let's actually take a look at the code I posted. Go over here. Where is my repository? There must be, oh, here. Okay, I hope you come here to take a look. So the code here looks pretty familiar to you, because this is the code that I actually do it on October 3rd. You have a GPS, you have thing, you have a person, you have a JV time. And this time, I actually introduce a new class called IoT thing. So I'm actually going to use thing as the parent class. I'm actually going to create a new class called IoT thing. So the thing is the parent, IoT thing is child. Let me actually first explain what's the difference between thing and IoT. So I make a very simple difference. IoT is a thing like a Swedish meatball. And the IoT thing means that Swedish meatball has an internet connection. It's connected. So that's why we call Internet of Things. Is meaning that you have a lot of small stuff, they actually can be connected together. Okay, so basically I'm saying a Swedish meatball with an internet connection. That's so let's first take a look at the thing. I clicked the wrong button. I want to click .h. So this code is actually almost the same as the code you have seen. Except I just want to tell you, I did something, I gradually cleaned the code to tell you that there is a different paradigm, that I actually include a bunch of things into one of the file called ecs36b common.h. So let me actually just show you what that code is, because by the way, this will be the base for your homework assignment number 3. Homework assignment number 3, you will be start doing inheritance stuff. So what's ecs36b common is basically I put a bunch of code which is related to the most commonly used library or things like that within this project. So I include it in everywhere. Otherwise, I have to put in one of the .h. Previously, I put under, I forgot, maybe person.h or GPS.h, which is not really a nice association. So now I actually take it out. So you can see that all this part, line 7 to line 18, everything is about C, C++ standard library. I'm actually going to put it in common. And then there is line 21 to 24. Those are the 4 include file I needed for the JSON, because JSON is needed by pretty much everything. So I have those 4 lines here. So there is a one thing which is new to you is I added the line 27, which is arpa/inet.h. So historically, if you have any Unix environment, if you want to deal with Internet Protocol, you have to include this file. ARP stands for ARPA. ARPANET is the first generation of Internet. It was developed in 1969. And Unix was developed about early 70 or 1969, around the same time. So this is essentially, this file was actually there, or this interface was there since about 1969. So that's actually pretty senior, but still very important. Okay, so that's why I put this here, so I can actually have an iNet, because right now, IoT, I have to include the network, so I actually have to include this internet over here. Okay, just let you know that this is the file. By the way, some of you asked the question is why I asked do this if not define, and then inside I said define, and then at the end I said and if. So the purpose of this, okay, you see that I actually put in every single include file. The purpose of this is that I don't want the same include file be included twice in a compilation. I want to make sure that it only get compiled once. If you, for example, if I include GPS and I include person, but person also need to include GPS, then I actually include GPS twice. But with this kind of code, I actually guarantee no matter how you include, no matter how your include structure is complicated, this file will only get include once. Why? Because the first time I got include, this ecs36b common _h has not been included. So that's why it's not being defined. But after I pass this line, this you see, if not defined this, after I pass this line, I define it. So which means that if I encounter the same file in the same compilation, I won't be able to pass line number 2 because it has been defined by line number 3 in my first encounter of this file. Okay, so that's the reason, just to let you know. This is a very useful way of make sure your include file got only included once. Okay, so let's actually look at thing. You should familiar with the thing.h is from the code. Again, you see I have the line number 2, number 3. I always do that to prevent this kind of problem. So I include 36b common.h, and I include person, GPS, Java, JV time. And then I have a class thing. You can see here, right now I put everything under public. So the first introduction of inheritance, I don't want to complicate between protected and private. Let's put everything into public, and then gradually we shift. And this is the same definition that it has a model number, sequence number, description, owner, purchase time, sold time, and location, right? That's the thing we actually define. This is something which we already have. I hope you remember that. And it has a function called dump to JSON. Okay. Now let's look at IoT thing. Now you can probably see what's going on. So this is IoT thing. In fact, you'll imagine it's kind of short. I mean, just adding, think about this. I'm adding internet access to a Swedish meatball. It's just a few lines of code. That's kind of convenient. That's, of course, hardware is hard, but from the software perspective, it's actually very, very powerful. You just adding a few lines, you actually can get internet connection to anything you want. So look at this. I said class IoT thing, column public thing. Okay, this actually declare an IoT thing is a thing. So everything thing has, IoT thing will have. And then everything else is the same because it has been inherited, but then I have an extra line. The extra line is on line 15. So line 15, I said IP address, Once it's connected, I need to have I mean, by the way, I'm actually using the most simple way to do IoT. So meaning that I preserve everything else, I just add the internet connection. Other than that, I don't care. All right, so I mean, that's good. And then I still have a constructor IoT thing. And the first one is a default constructor. The second constructor, I actually change it because if you remember in thing, that's actually has only one argument. If you go back to thing, where's thing? Thing is here. So thing is essentially only one parameter, right? The owner, that's the only argument. But the IoT thing, I actually modify the constructor such that the IoT thing is actually person, argument, owner, and the second one is argument connecting. All right, so you can see that I inherit, I change a little bit about the attribute or has a relationship, and I could or could not. This is my choice. I actually changed the constructor format to include new information, and the rest are pretty much the same. And of course, I do want to introduce this. Where do I define IP address? I actually define in the class called network.h. I define this. Let's actually take a look at network.h. This is a new class. So this is network.h is included there. You can see that in the network.h, because I imagine that network might have a layer 2 network, layer 3 network, Bluetooth, or any kind of other kind of application network. So I only started with IP network, internet, IP address. By the way, this is the IPv4, internet protocol version 4, not v6. So what I did, you can see that this class I define, I actually have is a IPv4. IPv4 means it's a 32-bit address. The only thing I include is this 32-bit address, which is unsigned in. Unsigned in, well, I actually should be more careful. In the most of the system today, unsigned in is at least 32-bit. But that was not true, say 10 or 20 years ago. At that time, integer could be 16 bits. That's the things that a C programmer or C++ programmer need to be very careful about using the size of to understand. So here I'm just do a quick and dirty implementation. So I use unsigned in because I know in my environment unsigned in is 32-bit, represent exactly the length or width of the IP address we're using today. All right, so I have a constructor IP address, and I have a another constructor which allow me to assign the IP address directly. I will show you the example. And then I have a bunch of attributes for me to access the address, and that's it, okay? Any question, by the way, before I move back to IoT thing? Any question about the definition of network? Okay, just want to tell you that object-oriented programming is something which really allow us to do modeling very quickly. You can see each of the file, I typically don't have over 30 lines in the .h file. I usually can define a fairly complicated concept, and then I can use this concept through inheritance to include, and then I can actually build a things like internet Swedish Mibble. All right, so now let's go to IoT thing .h. So I have this, and I have this dump to JSON, and just forget about this word virtual I added here because I'll show you a bit later, maybe on Wednesday. The things I want to tell you is that after I define this, the only tricky part you need to worry about is this constructor, because IoT thing is a thing, and the thing has a constructor, and IoT thing also has a constructor. But IoT thing also include all this has a attribute that define the thing. So that constructor needs to be called as well. So let me actually just show you virtually how the constructor is called. Then let's go back to the example. So the way it works is like this. Let me pull out my code. Where's my code to show that? Is this probably, yeah, this one. Okay, so here I use the word base and derive. So you can think about base is the parent class or the thing. And derive is IoT thing. So when you call constructor, what it does is that when you actually want to construct the child, the first thing you're going to do is call constructor. But before I actually call my own constructor, I need to call my parent's constructor. If you only one parent, if you have like a multiple layer parent, looks like this. Then essentially when I create a teacher object, I need to try to call faculty's constructor. And faculty realize that, okay, wait a minute, I still have a parent, so it will call employees constructor. And employees say, I'm not the root class, so employee is going to call community members constructor. Finally, the first function got executed is community members constructor, and then employee, then faculty, and finally teacher. So that is a general way of looking at this. So wait a minute, where's my, yeah, here. So essentially between IoT thing and the thing, I'm actually going to ask you the things constructor first. Finish, then I'm going to ask you this. So let's now go back to the code to see how it works. It looks like this. Where's my GitHub? I'm actually now going to IoT thing.cpp. Okay, this is IoT thing.cpp. For the default constructor, you don't have to say anything. But for the non-default constructor, non-implicit, you have to say this. You see that I'm actually, this is the function signature for the constructor for IoT thing. Okay, here's a syntax. You have to put a colon to say, hey, now I'm going to give you my parents constructor. And then you're actually going to write thing. This thing means it's a constructor thing. You're going to call the constructor a thing, and here provide this as argument. Because remember that thing's constructor, that particular constructor take one parameter, which is the owner. That's why you basically pass this argument, sorry, this first argument into the constructor. And the execution order is that it's actually going to invoke that constructor first, and then they're going to do this. Okay, so let's actually take a look at the code anyway. So you can see that in my IoT thing.cpp, I don't have to initialize anything except the new attribute, which is connected, the IP address. And that's why in my constructor, I only need to call that one, and that's done. Okay, that's the only thing I need to do.
So I can't call the parent constructor inside the function. What if I just like
I know what you're saying. That's a good question. I don't know. I never done. When I say I don't know, I never done that. So let's try to see if that will work. Okay. Well, the first thing is, how do I know it's actually a parent constructor? This is a code, by the way, the same as you. So let's do. So let me ask the question as well. We have a Java programmer in this class. Will you be able to, how do I say that? In your control to actually decide exactly when you're going to call the parent's constructor for Java programmer? Anybody have any experience like that? Yeah. Okay, okay, okay. Yeah, I don't think we have a super in C++. But it will be interesting. Let me actually try to see if this will work. Let me try to do this. I actually have to cast this to thing, right? If I do this, I'm actually casting IoT thing into the parent, right? I have to first convert myself to a parent. And then I will call thing. And then I will say ARG owner. Let me see if they allow me to do this. Okay, so that's my way of actually calling parents constructor, but I don't know whether this is allowed or not. I never done it. Yeah, it doesn't allow me to do that. Let me see this. Can I do this? Can I try thing, calling thing? That's the only thing I can think of. Yeah, I cannot do that. So there might be a syntactic way I didn't know I can make this happen.
But the standard is just to call the parent between the function army.
Right. Right. Before that, before you actually call yourself, that is the tradition is always recursively go all the way up. Yeah. I mean, the other thing is, if you think about this, sometimes it makes sense for the software safety point of view, because sometimes if I haven't configured my parent and I directly use something in the child, I might actually causing error. For example, I haven't actually configured my brain and I start try to configure something else, and that might be an issue. Yeah. Okay. So, but that's a good question. I actually don't know if there is a way I can force it to do that. Let me actually block this one. I will figure out later what's going on. Okay. Any other question about IoT thing? Yes. Which line you're talking about? Oh, carton. Okay. Okay. What did I do here? It looks different. Oh, I make a mistake. I should say public. If I don't say public, the default is public, I think. So I didn't say public. Okay, I'm surprised. Okay. I did say public, right? Yeah. If I don't say public, I think it will still work. I thought the default is public. Yeah. It could be most 99% of the case. When I do inheritance, I always do public, because when I have a protected private, sometimes private is really rarely used. Protected occasionally, but public is the most common way of doing application. Okay, does that answer your question? I still using public, right? Or did I actually upload the version of the code? That's
the default is private.
Oh, default is private. Okay, so maybe I should. You're right. Thank you for correcting me. So we should actually say public. Yeah, go ahead. Yeah. Thing.cpp. Yeah. This is thing.cpp or IoT thing. Thing.cpp. Okay. IoT thing.cpp. Yeah. Okay. How should I rewrite this?
That's the class name. And,
That's the default way of doing constructor. So you might be confused a little bit because over here, this is number one. Those codes are number one. The code is actually equivalent of .h file, like this file is .h file. The second thing is that we're not doing separate compilation. So it actually includes all the implementation of the code inside the class definition. If your code inside the definition, you don't need to add IoT thing, colon. It's only when you do separation. When you do separation, compiler need to know this function is defined for which class. That's why I need to specify the class name. But inside here, the compiler won't be confused because they know it's already in the class content in the same scope. Yeah. All right. Any other question? Okay, let's try to run the program. The other thing I do want to mention is about the dump to JSON. So the way I implement, you can see that when I implement is I actually call the parents dump to JSON. And then I actually integrate the result into the JSON from the parents, and then I return the result. So just let you know that we go over this dump to JSON last time. And so you will see the result going to be somewhat different because of this. Okay, so now I'm actually going to the test program for homework 3. So this is, by the way, it's not a homework 3 test, but it's actually related to homework 3. So from the beginning is all the same, okay, about Home Woodland, TLC UC Davis, IKEA Sacramento, and Persons of Felix, and the thing is Swedish Meeple. But now what I did is look at line 20. The line 20, I actually have this huge number, 285088, but that remember was IP address is a 32-bit integer. So I actually construct IP address with that integer. How do I get that integer? It's actually, I do the IP converter. I just enter 169.237.6.102. When I convert, it's actually convert to this integer, 32-bit. By the way, it's huge, but it's 32-bit integer. And I include that integer in the code. All right, so let me go to my code. No, I don't want to come here. I want to go to GitHub. Yeah, so I basically use that integer to create an IP address object called Meeple_IP. So I basically provide IP address, and then you see now I'm not creating thing as I show you in October 3rd, but instead I create an object called IoT thing, Swedish Meeple, Felix, and Meeple IP. Okay, so now the constructor take the person, owner, and the IP address, and the rest are all the same. The rest are all the same, and the only thing that's interesting at the end, I actually do a Swedish Meeple dump J, and let's see what happened in this code. Let me make this a little bit bigger. Okay, so I have this program and I just run it. Okay, so I'm actually running this program. You can see that the second part of the dump is dump for Swedish Meeple, right? So this part is dump for Felix. The second one is dump for Meeple. And now I have a connected, right? I have a print. I mean, I basically, if you were here on October 3rd, you will see that the output is output just like this. And now I'm just adding another output, which is connected, and IP address looks like this. It's based on the way I wrote the dump to JSON. Okay. So any question? Have you realized something is wrong? What's wrong? Is the IP address looks good to you?
Oh, no, it's not.
It's actually reverse. You see, it's a 169.237.6.102 is reverse. You see here, if I go here is 169.230. By the way, IP address 169.237 is the UC Davis address. Subnet 6, the 6 belong to computer science. 102 is one of the device in the computer science network. Okay, so is exactly opposite. You see, when I print it, it's actually 169.237.6.102 from right to left instead of from left to right. Anybody want to guess what's going on? Okay, this is something which I want to tell you that when we deal with network programming, there's two kind of order. One is called network ordering, one is called host ordering. And they're sometimes the same, sometimes opposite, depending on what is the platform. It's basically saying that how do you interpret each of the bytes in the string? So for example, if I actually receive 4 bytes as an integer, is the first byte the most significant byte or the last byte is the most significant byte? So when you do network programming, you have to be very careful. It's about the difference between network ordering and the host ordering. So network ordering never change. It's always the same because internet. But host ordering sometimes make a difference. So in order to solve that, let me actually tell you, this is unrelated to ecs36b, but this is a good knowledge for you to have. If you go to my network.cpp, you see, when I actually print the address, this is how I print. This part is actually related to the arpa/inet.h. The file I actually included because I need to deal with this. So if I directly use this address and fit into the ARPA, the IP address structure, in order for me to construct everything, to use this function called inet n2a, n is a network address, to ASCII. That means I input integer into this structure, it will automatically convert to me this nice string, 169.237.6.102 from that integer I provide. But that's only assuming your network address is actually follow the same order. The most significant byte is the first byte or the last byte. So over here, I realized there is a problem. So that's why I have to use a function called h2l, h2nl. So I'm going to change this. If you compare this two lines, is I actually convert. This is called h2nl, is host byte order converted to a network byte order in a 32-bit integer format. So that's called h2nl. I have to use that to convert that number we just enter and send it to the network. And now if I just look at this, and then I run the program again, and now this time it actually showed me the correct address, 169.237.6.102. That's the network ordering. Sometimes you need to worry when you deal with internet programming. Okay, I think I'm almost done. So now I'm actually going to cover the last part, and then we can continue with the last part in a little bit more detail. Okay, so we're here. And we have the parent class and the child class. And we actually worry about the constructor, how to get it to work, how to define that. And now we're going to touch those keywords: private, protected, and public. And how do I actually be able to use those keywords in the inheritance case? So when I do inheritance and we say class IoT thing, colon, public thing, I can also say protected, or I can say private, meaning that this is the mode. This is not the three keyword. This is the mode when I say in the inheritance looks like this. Let me actually go back to the code. It might be easier to see it this way. So in the IoT thing.h, over here, I set public, but I can also say private, or I can say protected. So over here, I have a three option. This is called the mode of the inheritance. This actually mandates how each of the sessions need to be handled, treated. So now I'm actually going back to this slide. It's my last slide I want to talk about today. And I will continue this a bit more on Wednesday. So when you actually say is public, if it's a public, then essentially the parent is protected, then the child is protected. So everything is the same. The parent is public, child is public. So that's actually for public. If you actually define as protected, then essentially your public in the parent become protected. Your protected in the parent become private. And if you define as private, then essentially everything become private. Okay, that's the definition. So I will stop here and we'll continue on Wednesday. Yeah.
I know we're at the end. I just figured I'd throw you a battery on.
Thank you.
Yeah, I know it does a lot of good now.
Thank you. Appreciate that.